passion and concern for him, and he has been quite explicit about trying to move forward state policies to further limit greenhouse gas emissions. Secondly, I think policymakers have been looking both to the north of Washington, to British Columbia, which has had a carbon tax for several years and has had experience with that, and then to the south, where the state of California has recently started to implement a cap and trade system. And so we have examples to our north and south, and both the governors of Washington and of Oregon have been part of a Pacific Coast collaborative effort that is aimed towards trying to get a price on carbon up and down the West Coast. Thirdly, last month, the International Panel on Climate Change issued the latest in a series of reports, which is calling for action, so a group of scientists calling for action to reduce global greenhouse gas emissions. So I think we in the business community are going to be asked to take a position on these issues to better understand the science and better understand the potential public policy responses. So with that in mind, we at the CleanTech Alliance, and I don't think I forgot to introduce myself, so I'm Daniel Malarkey. I'm with Bunn Energy Systems, and I chair the Washington CleanTech Alliance's Government Affairs Committee. And so we in the Government Affairs Committee at the CleanTech Alliance said, you know, we are going to be asked to take a position on some approach to reducing greenhouse gas emissions. We ought to get smartened up on that, and that desire was shared by our colleagues at the Chamber of Commerce. And so we have put together a four-part series. The first today is focusing on climate science. I think you can see this schedule up on the screen, and it's also in this handout here. On Tuesday, May 27th, and that was a date change from the very first thing that went out, we're going to hear from Dennis McLaren and Keith Phillips talking about what's the current state and federal regulatory and legal framework for limiting carbon emissions, really give us a foundation in terms of what's the existing public policy regime that we're working under. And then we're going to hear from folks talk about what the experience of BC has been, and then also what the experience of California has been. So that will all wrap up on June 30th. So I really do invite all of you to attend all 4 sessions. This is a big, complex issue. It affects all of us, and I think the better informed we can be as a business community, the more likely we're going to get policies that work for us and work for the environment. So I want to thank the Seattle Chamber for co-sponsoring this event with us. We have worked with them to get the word out. There's a little survey here that I want to draw to your attention. It's confidential. If you all could fill this out, that would really help us better understand how you got here and how we can better communicate our message and get more folks informed on these issues. I want to thank our staff. You'll hear from Tom Rankin, our president from the CleanTech Alliance, here at the close of the session. And Sharon Shirley, who has really done all the work. So thanks to you very much. So now I'd like to turn it over to someone who needs no introduction if you live in Seattle, and a great meteorologist, a great television personality, and a great member of our community, someone who's really been involved in everything from trying to advance science education to helping host forums like this to help us all be better, more informed citizens. So with that, I would like to ask you to join me in welcoming Jeff Renner, Chief Meteorologist at King 5 News.
I'm glad this isn't Thursday when we're likely to hit 80 degrees, and somebody said if we walk out here with 2 things, better understanding of the topic at hand, but we want to know, is it really going to hit 80? I've got to go back to the Weather Center and look at that in greater detail right now, but if it was Thursday, I suspect a lot more of you might be taking lunch outside. So it's very nice to see all of you here. Undoubtedly, as each of you drove or walked here, you may have checked directions using a smartphone similar to this one. The benefit of having GPS and satellites that orbit the Earth. You probably have checked your email a number of times. I'm looking around, I don't see anybody checking their email just now, from friends, colleagues, business associates, not only here in the Seattle metro area, but all over the United States, and for that matter, around the globe as well. These technologies that have enhanced life and business offer evidence that the world is in fact becoming a much smaller place. And the borders are becoming much, much more permeable. That's vital, and we are seeing that on an everyday basis. And I think the atmosphere is a prime example. It knows and respects no borders. And I think as each of our three speakers come up, that's a statement they'll definitely all agree on. As a forecast meteorologist and as a former commercial and instructor pilot, I know that. And believe me, some people often say that one of the difficulties in terms of really getting motivated with this issue of climate change, of global warming, you can't see CO2. Well, I know that what you don't see can bite you. If you ever fly through an area of wind shear, you will know in a hurry that what you can't see can definitely be of concern to you. As a forecaster working here in the Pacific Northwest, the need to get data, good data, on what is happening not just in this region is of a prime importance. What's happening up in Canada, what's happening over the Pacific Ocean Basin is key to us being able to come up with a successful forecast and giving all of you a good idea so you can better plan your day, your week, and perhaps most importantly, your weekends. As we learn more about patterns such as El Nino and La Nina, how many of you have heard of those names before? Okay, most of you have. All of which impact seasonal patterns. We have to examine weather patterns data over a much bigger expanse of the globe and a longer time span. We've had to consider elements that frankly we never had to consider before as forecasters. And in each of these, we've been the objects, if you will. The atmosphere has been both the subject and the verb. There's increasing evidence that we are beginning to share the driving duties, however, in determining our long-term climate, if not short-term weather, and that's something that we'll be talking about here shortly, that we have and are influencing our environment in ways that may be costly, not only in terms of the weather, but in terms of economics, in terms of security, and in terms of health. In recognition of this, the Nobel laureate atmospheric chemist Paul Crutzen says that we are now in a new geological age, what he terms the Anthropocene as opposed to the Holocene. The Holocene describing, and I have all these experts at the table in front of me, I better make sure that they're nodding, since the glaciers retreated, that they are saying that more and more we are becoming a major driver of our environment as opposed to being acted upon by that environment. That is posing, I think, to all of us some very important questions and challenges. And as you wrestle with these decisions, as business owners, as business managers, in your professional life and your personal life, there's a need for more information. Science needs a seat at the table, not the only seat by any means. There are many different issues and elements affected, but it needs a seat. And that, of course, is why we're here today. So at this time, I'd like to introduce the three members of our panel. Ask them to join us up here. I'll move the microphone for the time being. And they're going to be offering you some information and perspective. We're going to begin by addressing the big picture and points of general consensus, the regional picture and where there may be some differences in perspective, and then also opinions on what might be done or what should be done. And there will be, by the way, ample time for you to pose questions. So, first I would invite Amy Snover to join us up here. Amy is the director of the Climate Impacts Group at the University of Washington. She is a climate scientist and heads an interdisciplinary team studying both natural climate variability and climate change and the implications for right here in the Pacific Northwest. And she has a PhD in environmental chemistry from the University of Washington. Cliff Mass, we'd invite you to come up. Cliff is a professor of atmospheric sciences at the University of Washington. If you've heard of terms, and I know you probably have, I'll do a survey, quick survey again. How many of you have heard of Puget Sound Convergence Zone? I could say this is the man that brought it to you, but actually not, but he has greatly enhanced our understanding of it, our ability to forecast it in similar local patterns, and developing forecast tools, including state-of-the-art computer modeling to forecast them. Cliff received his PhD from the University of Washington. And Andy Bunn, we'd invite to join us. Andy is an associate professor of environmental science at Western Washington University. He is director of the Institute of Energy Studies. The institute focuses on both the production and the use of energy, combining the fields of science, engineering, and technology with a view to business management, economics, policy making, and sustainability. He earned his PhD in environmental science from Montana State University in Bozeman. And so I'd say welcome and thank you to each of you for being a part of this discussion. I'm going to, I think the microphone is on. I would like each of our panelists, we didn't want to give way too a long bio. We have a lot of ground to cover. We know you have a lot of questions you'd like to ask. But to give each of them an opportunity to maybe give a brief 1-minute summary, and I'm enjoying being up here and being the one giving the time cues, and enforcing them, by the way, as opposed to being the person in front of the camera that gets somebody waving wildly at me and having people shout into my ear. So again, I'd invite each of you, and we'll start with you, Amy, to maybe give a 1-minute summary of a program and effort you've been involved in that you really feel is making a difference or will make a difference.
Thank you very much. The side button?
Can everybody hear it?
No.
Yep, it's on.
Yep, right there. Let's move.
It is working.
It's on.
Just like right up here.
Like right up here. Thank you very much, Jeff. Thank you, everyone here today. Amy Snover, Director of Climate Impacts Group at University of Washington. What am I most proud of? I am most proud of the past 15, 16 years I've spent with the Climate Impacts Group, which is an interdisciplinary group of researchers and professionals in policy and outreach who have made it their mission to understand what global climate variations and change mean for the region, and what they really mean, not just for the regional climate, but for everything that is happening on the ground in the region, from water resources and forest fires to infrastructure and public health. And it's just a terrific group of people and a terrific mission to bring climate science to use for the public interest in developing regional resilience, which is really to say that our in addition to the main research, we do quite a bit of translation and outreach with the intent of making the research meaningful, useful, and used.
Cliff.
Can you hear me? Okay. How do you summarize a life? I don't know. I do a lot of numerical modeling on weather forecasting, on regional climate modeling. I've done about 70, 80 papers on Northwest weather. I work on the coastal radar. I have a blog, and I do all kinds of stuff. So I'm interested in weather and climate, and I've done a lot of work.
Thank you all very much for the chance to be here. I think I'm Andy Bunn from Western Washington University, coming down from the provinces here to sit with the big dogs. And I think what I'm most proud of is that starting in 2010, I had students taking my climate classes coming to me and saying, I'm interested in climate, therefore I'm interested in energy. Because I think one of the things we'll mention today is that our climate change problem is ultimately a problem with the way that we use energy. And they were asking me what kind of classes there were in energy at the university. And it turns out there were a lot. There was neat stuff happening in economics and business, and there was neat stuff happening in engineering and science. But there's no way for a student to do both of those things unless they wanted to spend 12 years at the university, which I'm okay with, but it turns out that other people aren't. We've got Joe Meyer sitting over in the corner here. Joe's an alum of one of our energy programs up at the university. And what we did was started bringing together people from the business community to sit them down and say, what do you need from graduates that have education in energy? And they said they need to understand the science, and the policy, the engineering, and the technology. And so I've been working to build that program. Even though I'm a sort of climate scientist by training, I'm sort of most interested right now in how we're going to shape a clean and efficient energy future. And it's been a couple of years of effort, but it's been fantastic.
Thank you very much. Why don't you hand the microphone back to Amy? We're going to begin our discussion by offering a sense of perspective and context, and I think that's one of the things that's an aim of all of us to walk out of here with. Obviously, we're especially interested in the local impacts of climate change, possibly current as well as projected, but it would seem useful to put that in the context of the global pattern. So I'd ask each of you to offer about a 3-minute summary from your perspective of the current scientific consensus of global climate change, and feel free to offer maybe a bit of a primer in terms of some of the basic elements that are bandied about in terms of greenhouse gases, the general consensus on temperature change so far and what we're expecting. So just by means of keeping this moving, 3 minutes each, when you get within 1 minute of the end, I'll hold up my forefinger so you know it's time to pass it on to the next speaker. Amy, if you begin.
Go. So I'm going to focus on what we understand about global climate change. And I have a couple of main points. One is it's real, it's us, it's important, and our choices matter. So we know that greenhouse gases are increasing rapidly, have increased rapidly in the atmosphere. Methane, carbon dioxide, nitrous oxide. We know that these will warm the climate. We've actually known this about carbon dioxide since the mid-1800s. In scientific papers published there. We know that these greenhouse gases are increasing in the atmosphere at unprecedented rates to levels that are higher than any experienced in at least the last 800,000 years. And we know that they're increasing because of human activities. And if we had more than 3 minutes, we could talk about all the lines of evidence that go into every one of those statements. But each one is based on theory, modeling, and observations, and developing a strong basis for each of them. We know that the Earth's climate system has warmed. And this is not just the atmosphere, but this is the ocean and the cryosphere, the ice, and those are the main parts. Most of the warming so far has gone into the ocean. We know that part of that is us. When I say it's us, I mean we can't let ourselves off the hook. While natural variability continues to play a very large role, the current consensus is that at least half the warming experience since the mid-20th century is due to human activities. And again, this is observations, theory, and modeling. We know this is important because we're seeing changes now. And again, anything we see now is a combination caused by human activities, influence on global climate, and natural variability, which continues to play. And will continue to play an important role as we go forward in time. So we have wide-ranging impacts. We've seen warming on the order of around 1 degree since the beginning of the 20th century globally. We've seen changes in precipitation patterns. We've seen the Arctic areas warming faster than the rest of the world, as we would expect from the physics of snow melting and it decreasing its ability to reflect the incoming energy. We also know that there's wide-ranging impacts in natural and biological systems around the world that have been observed, from glacial retreat to earlier onset of spring, to changes in migration patterns and centers of populations for birds, all of these documented through things like Audubon and other networks. And again, any one of these by itself cannot be attributed all by itself to our influence, but it's a part of the problem. We know that more change is projected in the future, and the amount of that change depends on what we decide to do about greenhouse gas emissions. If we continue to increase now with business as usual, we might see an increase by the middle of the century of around 6 degrees Fahrenheit compared to the middle of last century. If we decide to get really serious about changing our energy sources, we might see an increase of only a little over 4 degrees. So our choices matter. The continued emissions will cause continued warming, continued changes across all the components of the climate system, and limiting climate change relies on human choices about deciding to limit it.
Very good. I don't want our producers to see you because they're going to say she keeps better time cues than you do. One thing I'd like to just, and I'll do this from time to time if you don't mind, 1 degree Fahrenheit or 1 degree centigrade?
Fahrenheit.
Fahrenheit, okay. And just, I know, and Cliff knows this, when I interview him, I always have to remind them, if you can't express it in terms of Fahrenheit and English units as opposed to metric units. Cliff, same point then, or same question if you would.
Okay, and this is about global stuff we're talking about?
Global and general points of consensus,
General
as you
points of
understand it or agree.
Okay, well, I mean, the basics I think everybody knows. We're talking about increasing carbon dioxide, methane, nitrous oxide, gases like that, and it's clear from both theoretical and modeling basis that it's going to warm the planet. Okay, that's pretty clear. Another thing that's clear is that global warming is not going to be uniform. It's going to vary substantially in a variety of ways. The poles look like they'll warm up more than any other place. Continents will warm up more than the oceans. It turns out that the eastern oceans will warm up less than the western oceans. And that's going to have big impacts. For instance, here in the Northwest, we're lucky to be downstream of the ocean, and eastern ocean, and it appears that global warming, or the effects of global warming, or the greenhouse gases, will be less here, and the changes will be slower here than in most other places because we're downstream of the ocean. So there's going to be all kinds of regional variation. In terms of precipitation, it looks like places that are dry today, like the subtropics, will tend to be drier. Places that are wet, north of us in British Columbia, etc., will tend to get wetter. So wetter will get wetter, drier will get drier. This is a general situation. But I have to note there is a large amount of uncertainty. I mean, there are issues with our models, and there's issues with knowing what's going to happen with the greenhouse emissions. So, I mean, the uncertainty is something that is extremely important. There's uncertainty at the global scale, and there's a large amount of uncertainty on the regional scale, even more so. It's something that we have to talk about. So I think that's enough.
That's great. It's a great summary so far. So I think the thing I would emphasize most is, kicking off from what Amy said, is that we have known that carbon dioxide is a heat-trapping gas for 100 plus years of careful physics. And when you put a heat-trapping gas in the atmosphere, you expect it to trap heat. That doesn't mean that there couldn't be something else causing climate change, but it's like when you go to bed at night and you put a blanket over you, you expect that blanket to keep you warm. It doesn't mean that a monkey's not going to come out from underneath the bed while you're sleeping and pull the blanket off you, but no one goes to bed expecting the monkey underneath, at least not until tonight, maybe, when you're going to bed. So, we do know that we put a heat-trapping gas in the atmosphere, it's going to trap heat. It's because that's the physics, and the physics is the easy part. The really hard part to figure out is what people are going to do about it. And I tell this to my students all the time, and I get a lot of students who are majoring in physics, and I say, it's great you're majoring in physics, I love physics, you chose the easiest thing to study. And they don't usually believe me, but it's true. The kids that are out there, the kids that are coming and really want to get messy and get involved with policy, the way that people are going to act, that's the hard thing. The physics is relatively easy, and it's what people are going to do with it that's the hard part.
It's harder than you think.
So.
Boy, you're making managing this too easy. Why don't we go back, and this is an opportunity to amplify that or maybe bring up a side issue. One question I would toss out at this point, because I think it's very often brought up, it's a theory, or it's just a theory. Would each one of you, or maybe one of you, if you feel especially strong, like to distinguish perhaps the public conception of a theory and how useful or reliable it is versus your understanding of that?
Next question.
I don't know, maybe something pithy to say about that is that the way that the word is used in science and the way that the word is used colloquially are very different things, and which is unfortunate. It'd be nice if we had different words for these sorts of things. But it's the same way that that gravity is a theory. Is the same way that we have these ideas of evolution as a theory, that we use these things scientifically as a way of thinking about them, not in the way that they're sort of expressed when we talk about a theory of whodunit in a mystery novel.
Okay. Why don't we go back and take maybe a minute or two for each one of you, and if you'd like to amplify on anything you said or bring up a side issue that's related to the global pattern, please do so. And Andy, do you want to start?
I think what Cliff said about this, what are we going to think about in terms of the impacts? And Cliff said, the wetter areas are modeled to get wetter, and drier areas are predicted to get drier. That's all borne out very well by the models are very consistent and consistent on that. But Yogi Berra is supposed to have said that prediction is very hard, especially about the future. And it's really important to keep that in mind as we move forward. But it doesn't mean, because there's uncertainty, it doesn't mean that we should use that as an excuse to just wait and see for what happens. Uncertainty can cut both ways. And when we think about climate predictions of what's going to happen to the atmosphere, we can think about things that are impacts that might be less than expected and impacts that might be greater than expected. There's been some interest in the scientific community about whether or not we've seen a decline in the rate of heating over the last decade in the atmosphere, and there's been a lot of interest in the scientific community about why the atmosphere might not be warming as rapidly as we thought it might, a decade ago. At the same time, Arctic ice is melting much faster than our models are predicting, and so there are the uncertainty cuts both ways, and we want to make sure when we're planning for the future that we're planning for a way that is going to keep us in the safest possible light as a society as we move forward.
Cliff?
It's kind of, I don't know what to talk about here, but I think it's really important that we tell the scientists, tell people the truth, that we tell them exactly what we know and what we don't know. And so I think this uncertainty is very important. In fact, I think it's very important for weather prediction. And one of the things that I'm working on is ensemble-based weather prediction, providing the uncertainty, probabilistic information. We have to do the same thing with climate. And that's one of the things that we have to do now is develop the tools to give people better probabilistic information about how climate is going to change. So, so the uncertainties are there, we can't hide them. We have to give people the honest truth, what we know, and then we let the political folks make the decisions on what society will do about it. That's not our job. Our job is to give straight facts.
Let's just, I'd like to interject a question. How many of you know what ensemble forecasting is? Okay, so maybe you could just amplify a little bit on what do you mean by that?
Right, well, the old technology of weather and climate forecasting would be to do one forecast, put all your computer power into it, highest resolution, best physics. This is what you think is going to be reality. But this is very bad because there's uncertainty. There's uncertainties in our initial conditions. There's uncertainty in the model physics. There's uncertainty all over the place. And so an alternative technology to get the idea about the uncertainty is called ensemble forecasting, where we run our models many times with different initial states, with different physics, with different forcings, and therefore getting a whole collection of forecasts. And from that, we can get probabilities. If, for instance, if half the models say at this point it's going to rain, and say it won't rain, well, 50%, right? Probability. But you can do this with temperature. You can do this with everything. So the future of forecasting, both weather prediction and in climate, is ensemble-based, probabilistic forecasting. In fact, the technology is even more involved, statistical post-processing to optimize that. That's the future. That's what we have to do for both climate and weather.
Okay, Amy, and thank you, Cliff.
So I would say that in large part, the future is now, because the way the climate projections that I quoted from take a look at these various sources of uncertainty and provide a range of potential futures. So when we look forward, we know for sure that we've altered the atmospheric composition. We know for sure that those are heat-trapping gases that will trap heat. And we know that under every single scenario examined, the atmosphere continues to warm. And if we shut off emissions today, it would still continue to warm for centuries, and sea level would continue to rise for millennia. So we know we have made a change in the Earth's climate system. What we don't know is exactly how much it will change, where and when. And to answer that question, we use things like ensemble forecasting of climate conditions. We use multiple different scenarios of future greenhouse gas emissions that assume different things about how society is going to grow and how much energy it's going to use to produce a certain amount of economic output. Those are parts about the future we can't really predict. And so we outline different scenarios that describe potential futures and examine the implications of each of those for a changing climate. And under every single one of those, it gets warmer. And under every single one of those, climate conditions change around the world. So our challenge as scientists in communicating this is to remain true to that diversity and to say, here's a projection for a future based on these assumptions about what the energy use is, or population growth, a low one or a high one. And it's also our responsibility as a society to look across these different scenarios and say, number one, which one do I want to live in? And number two, am I going to be able to, how well are we prepared for the consequences?
Very good. Okay, well, let's go into the next point, and there will be again an opportunity for all of you to raise a hand and ask some questions on this area and have our speakers amplify those points. But let's move on to the next issue, and that's the one of local impacts, and that's probably one that's going to be of greatest interest to many of you. What we would do is, why don't we start out with Cliff this time and work back through each of you, and why don't you take about 2 minutes to talk about your sense of what we're looking at. And Cliff gave a hint of that a little bit, but I'd like you to amplify that a little bit on what do you see in terms of the impact of climate change on those of us that live and work in the Pacific Northwest.
Sure. Well, as I mentioned before, we're lucky to be living in a place where the impacts of global warming will be slower and probably weaker than most locations. So that's because we're downstream of the ocean. So we're very fortunate in that respect. But we will see the impacts here, especially later in the century. It's kind of an exponential. It's very slow now. Right now, the implications of what humans have done to the gas in the atmosphere are very small here compared to the natural variability. So right now, most of it's not very much human caused. But by the end of the century, that's going to be different. The signal that we're producing is going to be much larger than natural variability by the end of the century. And we have our models that the best we have, and they suggest that we will see warming. We will see that the snowpack will be less, which will probably be the biggest impact here is the loss of snowpack later in the century because we use that for water. But we will have the same or more precipitation over the year. So we will not lose precipitation like the Southwest may. So less snow, higher snow level, same or more precipitation. That's what looks like our future. I have a student now working on heavy precipitation, and it looks like we'll have more heavy precipitation events mid and later in the century. So they can think that's pretty solid right now. Again, I want to stress that up to now, the changes have been very minimal around here. And in fact, if you look at the snowpack hasn't changed in 30 years. The snowpack has not declined, as some people have been suggesting. So, I mean, the changes have been relatively benign. There's no hint that storms are getting more intense or anything crazy going on. One final thing I should say, there's a lot of surprising things that may happen at the end of the century. Right now, our high-resolution regional simulations suggest there could actually be more clouds in western Washington under global warming because the interior will heat up and the pressure will fall. I can talk more about that later. Okay?
Tourism folks are not going to be happy to hear about the clouds, I suspect. Why don't we pass that now on to Andy?
We are blessed in this region for the wonderful quality of life we have, the wonderful climate, the wonderful landscapes we have. We're also blessed as an economic entity because of our incredibly cheap electricity. We have some folks here from PSE, from Seattle City Light, and other places from the Snohomish PUD have seen that bring us this wonderful cheap electricity on which our economy is based on. And why is our electricity so cheap here?
Hydro.
Okay, and where do we get hydro from? Where does that come from? Magic comes from the sky, right? Because of our precipitation. We need to make sure that our areas of uncertainty, as Cliff has said, on understanding things like snowpack as we move later into the century are incredibly important for us to continue to study as hard as we can for both reasons of, the western mountains are the water towers that provide irrigation, they provide food. They're the water towers that water as it falls produces a tremendous amount of energy for humans to use, and we have to make sure we get those right as we go forward. So that's something for local impacts that we need to make sure we're very careful about.
Amy.
Great, I was afraid I was going to have to go first every time, so this is lovely. Thank you, Jeff. So just to give you some numbers from the work that we've done and others have done to translate global climate model output into local impacts. I misspoke before. The numbers I told you for a 4 to 6 degree warming by the 2050s, that was actually for the Northwest. It's slightly larger for the globe, as Cliff says. So, as everyone said here, the main impact of that warming is an impact on our mountain snowpack. And that is essential not only for hydro and drinking water supply, but also the timing of that water availability is the timing to which our natural ecosystems are adapted. So that means forests and their fire risk, and that means aquatic ecosystems like salmon, many of which are endangered, so we need to care about them whether we care about them anyways or not, right? We have sea level rise projected off our coast, and again, this is a large range depending on what kinds of emissions happen and the uncertainty associated with that. So I think when we think about whether climate impacts matter and when they will matter, if they're going to matter not until the end of the century or if they're going to matter next year, we can't answer that question just by looking at the size of these changes. So I can tell you that the models say that on average, depending on the scenario, we're likely to have about 40% less snowpack at the end of the year in the Cascades in the 2040s. And some people may say, that's not a big deal. And other people might say, the sky is falling if that happens. And they're probably both right. And that depends on why they care about snow and how big the reservoir they have to catch the water that isn't snow is, or whether they're a fish living in a stream that needs to be kept cold by snow, or how big their demand for drinking water is in the community that they serve. So I think that the really important part about the dialogue about whether these impacts matter or not is the next step, going beyond the numbers about temperature and precip and snowpack and sea level rise, and looking at implications for economies and communities. And if we had more than 2 minutes, we could do that too.
Why don't we pass, actually, you're going to have more than 2 minutes, because we're going to cycle back through you again. Cliff, I'd invite you to go first, and then we'll cycle back through with a chance to either amplify or react to some of what's been said.
Well, I mean, we're going to have an interesting decision to make. It's going to warm up, there'll be less snowpack, but we'll have as much, if not more water. So we're very fortunate. We're not like the Southwest. So we could do something about it. We could save that water. So, I mean, if global warming is going to happen, well, we're in good shape. We need more reservoirs. We need more dams. That may have ecological impacts, right? It may affect fish or whatever, but we could save the water. That would allow us to keep our agriculture and our urban areas going. So, I mean, we're very fortunate in that respect.